Hello my dear children, welcome to the mathematics class. Today we are going to discuss continuity and differentiability. Continuity and differentiability. In this chapter we discuss exercise 5.8. Exercise 5.8. The concepts or points of exercise 5.8. There are only 2 points. There are only 2 concepts we are going to discuss. What are the 2 points? First one is Rolle's theorem. First one is Rolle's theorem. And the second one is mean value theorem. Second one is mean value theorem. Here we need not to prove these 2 theorems. Directly we use these theorems to solve the questions. So here we discuss only statements of Rolle's theorem and mean value theorem. Okay my dear children, are you ready to listen the class? Right. Now come to the first point my dear children. Rolle's theorem. Rolle's theorem. Let f is a function from closed interval a comma b to R. Here f is a function from the closed interval a comma b to set of real numbers. Be continuous on closed interval a comma b. It should be continuous. The function should be continuous on this closed interval a comma b. Remember this point my dear children. This is the first condition. And differentiable on open interval a comma b. This is the second condition my dear children. In this theorem, in the Rolle's theorem, f, the function f should be differentiable on open interval a comma b such that f of a is equal to f of b. Remember this point my dear children. This is the third condition. In the Rolle's theorem, this is the third condition, where a and b are some real numbers. Where a and b are some real numbers. Understood this point my dear children? Here there are 3 conditions should be satisfied by the given function f. What is the 3 conditions? First condition is it should be continuous on closed interval a comma b. That is the first condition. And the second condition is f should be differentiable on open interval a comma b. That is the second condition. Remember these 3 conditions my dear children in the Rolle's theorem. And the third condition is f of a is equal to f of b. Okay my dear children, these 3 conditions should be satisfied by the given function f. Then there exists some c in open interval a comma b such that f dash of c is equal to 0. In that case, if the given function f satisfies these 3 conditions, if the given function f satisfies these 3 conditions, what are the 3 conditions? I repeat that 3 conditions one more time. F should be continuous on closed interval a comma b. That is the first condition. And the second condition is f is differentiable on open interval a comma b. That is the second condition. And f of a is equal to f of b. It should be satisfied. These 3 conditions should be satisfied by the given function f. Then we can find c in the open interval a comma b. Between a and b we can find a number, a real number c, such that f dash of c is equal to 0. Okay my dear children, understood? See here we are representing this Rolle's theorem geometrically. This is a given function, graph of this given function f of x graph. If you observe here, at a and at b, f of x values are equal. F of a and f of b are equal. Understood this graph my dear children? Here f of a and f of b are equal. It is a continuous function in this closed interval a comma b. F is continuous. There is no jerks. There is no break. Okay, my children. So this is a continuous function in this closed interval a comma b, and it is a differentiable function in the open interval a comma b, and f of a is equal to f of b. These three conditions are satisfied. In this case, we can find some real number c, in this open interval a comma b, such that f dash of c is equal to 0, means the tangent drawn at c, it is parallel to x-axis. F dash of c is equal to 0 means the tangent, if the tangent is drawn at this point c on the graph, it is parallel to x-axis. Understood this graph, my children? Right. Come to the second graph. This is a graph of f of x. This is graph of f of x. If you observe here, a, f of a, and here it is f of b. Both are equal. Then in this closed interval a comma b, the graph of this function is continuous. There is no break, there is no jerks. So it is said to be continuous in this closed interval a comma b, and it is differentiable in the open interval a comma b. In this case, see here, we can find c1 and c2. Not only one real number, we can find it more than one real numbers also in the open interval a comma b, such that f dash of c1 is equal to 0, here f dash of c2, these two lines are parallel to x-axis. In this case, we got only one real number at which the tangent is drawn. It is parallel to x-axis, whereas here we can find two values, namely c1 and c2. If we draw tangents at this point on the graph, the tangents are parallel to x-axis. Understood this point graph, my dear children? Right. Now come to the second point, that is mean value theorem. Sometimes it is denoted by m.v.t, mean value theorem. Understood this point, my dear children? Short form of this statement. Now come to the statement of the mean value theorem. Let f is a function from closed interval a comma b to real numbers, be a continuous function on closed interval a comma b. Understood, my dear children? Here f is a function from closed interval a comma b to set of real numbers. Then the first condition here, is f should be continuous on closed interval a comma b. Remember this first condition, my dear children, in the mean value theorem. F must be a continuous function on closed interval a comma b, and the second condition is f should be differentiable on open interval a comma b. In the case of Rolle's theorem, there are three conditions, whereas in the case of mean value theorem, we have to verify, we have to check these two conditions only. What are the two conditions? I repeat the two conditions, my dear children. Listen carefully. F must be continuous function on closed interval a comma b, and the second condition is it should be differentiable on open interval a comma b. Okay, my dear children, remember these two conditions when you are solving a sum related to mean value theorem. Okay, my dear children. Then there exists some c in the open interval a comma b. In this interval, we can find some real number such that f dash of c is equal to f of b minus f of a by b minus a. Understood, my dear children? We can find some real number in this interval a comma b such that f dash of c is equal to f of b minus f of a by b minus a. So let us represent this mean value theorem geometrically. Okay, my children, see this one, x-axis and y-axis. this is a graph of f of x. This is a graph of f of x. Here we have taken a and here we have taken b. In this closed interval between a and b, the graph of the function is a continuous function. It said this one, the condition is it should be continuous in this closed interval a comma b. Yes, that condition is satisfied. And second one is it should be a differentiable on open interval a comma b. So it is a differentiable in the interval a comma b. Then we have found some real number c in between a and b such that f dash of c is equal to f of b minus f of a by b minus a. It means if you draw a tangent, to the given function at point c, if you draw a tangent to the given function, it is parallel to this line. It is parallel to the line joining these 2 points. Understood this point, my dear children? Right. Now, before going to start exercise sums, please remember these 3 points also, my dear children. Note, every polynomial function is continuous on closed interval a comma b, where a comma b belongs to real numbers. Okay, my dear children, remember this point. Every polynomial function is continuous on closed interval a comma b, where a comma b belongs to R. Okay, my dear children, remember this point. Second point, every polynomial function is differentiable. We can say that derivable also. Both terms denote the same. Okay, my dear children. So every polynomial function is derivable on open interval a comma b, where a comma b belongs to R. Okay, my dear children, these are very important, very useful points for exercise 5.8. Okay, my dear children. Now come to the third point, greatest integer function. This function is also said to be step function. Greatest integer function or step function, both mean the same. Is continuous only in the interval n comma n plus 1. It is a continuous function between two consequent integers. Okay, my children, where n belongs to z, and not differentiable at integral values. Greatest integer function is not differentiable at integers. Understood these 3 points, my dear children? Remember these 3 points, my dear children. These are very useful for exercise 5.8. Okay, my dear children? Right. Now come to the sums in exercise 5.8. We are going to start the problems in exercise 5.8. Page number 186. Page number 186. See the question number 1. First question. Verify Rolle's theorem for the function f of x is equal to x square plus 2x minus 8, comma, x belongs to closed interval minus 4, comma, 2. Understood the question, my dear children? We had to verify the Rolle's theorem for the given function f of x is equal to x square plus 2x minus 8, and the interval is minus 4, comma, 2. Okay, my dear children? Right. Now come to the solution part. We have written the given function. What is the given function? F of x is equal to x square plus 2x minus 8, comma, x belongs to closed interval minus 4, comma, 2. Okay, my dear children? So to verify Rolle's theorem, first of all we have to check whether it is satisfying the conditions of Rolle's theorem or not. Previously I told you, when we are discussing the Rolle's theorem, there are 3 conditions should be satisfied by the given function. What is the first condition? f should be continuous in the closed interval. So see that first condition, f is continuous in the interval minus 4 comma 2, closed interval minus 4 comma 2, as it is a polynomial function, and the polynomial function is always continuous. We know that polynomial function is a continuous function, so on any interval it is continuous. So the first condition is satisfied by this given function. Understood this point, my dear children? Right. Now come to the second point. What is the second point? The function should be differentiable on the open interval a comma b. See here, f is differentiable on open interval minus 4 comma 2, as it is a polynomial function. Previously we have discussed this point also, my dear children. Every polynomial function is differentiable on any real number. Okay, my dear children. So the second condition is also the second condition of Rolle's theorem is also satisfied by the given function. Now come to the third condition. Understood this point, my dear children? Right. Now come to the third condition. What is the third condition? F of A is equal to f of B. Both should be equal. What is A here? Minus 4. What is B here? 2. A means first number, B means second number in this interval. So let us find f of A, that means f of 4, that is equal to minus 4 whole square plus 2 into minus 4 minus 8. We substituted x is equal to minus 4 in this function. Understood this statement, children? Right. That is equal to minus 4 whole square. What is the value of minus 4 whole square? 16. Come to the second term, 2 into minus 4. What will you get? 2 plus into minus, minus a sign. 2 4s are 8. Understood this second term, my children? Right. We are writing minus 8 third term as it is. By simplifying these three numbers, what will you get here? 0. Understood this step, my children? Right. Now we find f of 2, means f of b. We are finding f of b, that is f of 2. Okay, my children? So we substitute x is equal to 2 in this function. So 2 whole square plus 2 into 2 minus 8. Understood this step, my children? Right. What is the value of 2 square? 4. Understood this first term, my children? Right. Come to the second term, plus 2 2s are 4. I wrote here. Understood this term, my children? Right. I wrote this third term minus 8 as it is here. Understood this step, my children? Right. By simplifying these three terms, what will you get here? 0. Here f of a value is 0 and f of b value is also 0. Both are equal. F of minus 4 is equal to f of 2. So the third condition of Rolle's theorem is also satisfied by the given function. Okay, my children? Understood? Right. So conditions of Rolle's theorem are satisfied. Understood, my children? We have verified that whether the given function is satisfying the conditions of Rolle's theorem or not. After that, we had to find C in the interval minus 4 comma 2. Hence there exists at least one C belongs to open interval minus 4 comma 2 such that f dash of C is equal to 0. So here we are going to find the value of C in this interval. Okay, my children? Right. Here what is a given function? F of x is equal to x square plus 2x minus 8. Now let us find its a differentiation. So f dash of x is equal to, what is derivative of x square? 2x plus, what is the derivative of this term? 2. What is the derivative of this term? 0. So I am not writing here 0. See, this is f dash of x. Understood this step, my children? F dash of x. Now f dash of c is equal to 0. We are taking this equation. F dash of c is equal to 0. This implies in this equation we are substituting x is equal to c because we are going to find c value. So f dash of c is equal to 0. Understood this step, my children? Right. This implies 2c plus 2 is equal to 0. 2c plus 2 is equal to 0. We substituted x is equal to c in this equation. Then we get this step. Understood this step, my children? Right. This implies 2c is equal to, if you are sending plus 2 to RHS, it becomes minus 2. Understood this step, my children? Right. This implies c is equal to minus 2 by 2. Understood this step, my children? Right. This implies c is equal to 2 gets cancelled. What will be left here? Minus 1. This minus 1 belongs to open interval minus 4 comma 2. This real number lies between minus 4 and 2. Isn't it or not, my children? So we have found a real number c between minus 4 comma 2 such that f dash of c is equal to 0. So Rolle's theorem is verified, means we have found the value of c. Understood, my children? Right. Now come to the question number 2. Question number 2. In this Roman number 2, there are 3 questions are there. There are 3 parts are there in this question number 2. There are 3 parts. I am explaining the first part of this question. Will you try yourself the remaining 2 questions, my children? Will you try them yourself, the remaining 2 questions, my children? Right. See the first part. Examine if Rolle's theorem is applicable to function f of x is equal to step x for x belongs to closed interval 5 comma 9. Understood this question, my children? We have to examine whether the given function satisfies the Rolle's theorem's conditions or not. Okay, my children? Right. Come to the solution part. Given function f of x is equal to step x comma x belongs to closed interval 5 comma 9. I have written the given data here. Understood this step, my children? If you observe the given function, it is a greatest integer function. Previously we have discussed greatest integer function is not continuous. It is continuous only in the interval n comma n plus 1 where n belongs to z. But here they are not consequent numbers, successive numbers. 5, 6. If it is 5, 6, then it is continuous. But 5, 9 is given, closed interval 5 comma 9. They are not consecutive numbers. Okay, my children? So see the first condition, f is not continuous on closed interval 5 comma 9 because f is a greatest integer function. So first condition itself is not satisfied by the given function. So conditions of Rolle's theorem is not satisfied. Understood this part, my children? Right. Hence Rolle's theorem is not applicable to the given function. If the conditions of the Rolle's theorem are satisfied by the given function, only in that case we say that the Rolle's theorem is applicable to the given function. Okay, my children? Similarly, do the remaining 2 sums in this Roman number 2. Will you do the questions, my dear children? Right.